So let's see how we apply some of these equilibrium concepts into doing some of the Conskill problems. So here, this is kind of, imagine this like a teeter-totter, the thing that little kids, bounce up and down on the playground. This is essentially a teeter-totter. Remember this, if we want to use our physics terms, this thing right here is called the lever. One thing that we haven't defined yet, when something teeters, right? This would be the pivot point. And actually it would be a little more like right there in the center. So that's the pivot point, right? And this triangle thing is what we call the fulcrum. So just so we're clear on like some of the terminology, a fulcrum is the thing that a lever pivots on. The pivot point is that point that the thing rotates around. And remember, the thing that's actually rotating, that's what's called the lever. All right. So now that the vocabulary lesson is over, let's get to these problems. Now this, it says, a uniform meter stick with equally spaced tick marks has a fulcrum at its center. A downward force of 2F, good. Another upward force, F, is then applied somewhere on this meter stick. And it tells us where should we apply that force F so that it's in equilibrium. And equilibrium is that term, if you didn't see the previous video, you can go look at it. But equilibrium just lets us know that the net torque is equal to 0. So when we add up all the torques, they should be 0. So this thing right here has a torque. Right, let's call this torque 1 and torque 2. Right, there's two torques, and when we add them together, they need to equal 0. So this one right here it's 2 tick marks away, and it's a force of 2F. And one thing you need to remember, in case you don't, is that torque is equal to the radius, or the distance from the pivot, times the force. Right? So the stuff we have right here, we have 2 tick marks away. So that would be, if this is R, how are we going to label this? Okay. This force, this 2F force, it's a force of 2F and it's 2 tick marks away. So 2 times 2 gives me 4F, right? And that's going counterclockwise, so that's a positive torque. And now we need to know, okay, where are we going to put this upward force so that it cancels everything out? Well, if I put an upward force over here, that would actually be still spinning counterclockwise. So that actually wouldn't cancel out the torque, right? That would still be a positive torque. So I need something that's on this left-hand side of the fulcrum, of the pivot point, because an upward force over here is going to be going clockwise, which is going to be counteracting that torque that we have right there. So I only have one force F, right? It's half the force of the original one. So if it's half the force, I need to move it twice as far out. Right? The only other way I can get a 4 here to cancel it out, if I put my force F here, right? That would be 1, 2, 3, 4 tick marks out. So a radius of 4 and a force of just F. But it is going clockwise. And remember, when we're talking about rotation, counterclockwise is the positive direction. Clockwise is the negative direction. Okay? So when we look at this, we would say, all right, that's a negative. And all of this still equals 0. I got 4F minus 4F equals 0. So I would need to put this force of F at the position x1. Okay, so this is the real mathy way of doing it. If you want to reason through it, you're like, I know that that torque is proportional to radius and force. So if I only have half the force I'm working with, I need to move it twice as far away. to get the same amount of torque. Okay, so let's take a look at the next one. Next one, we have a uniform meter stick with equally spaced tick marks, has a full blah, blah, blah. Okay, we have this downward force here. So this tells me I'm at 1, 2, 3, 4 tick marks out with a force of F that is going clockwise. So that is F's torque. The torque is equal to negative 4F. That's the radius, that's the force, right? And it's negative because it's going clockwise. So we got that. We need to cancel that out with a force of 2F, right? So we have double the force that we're working with. So if we have double the force, we would only need to be half as far away from the pivot point. So we have a downward force. So you're like, all right, well, maybe it goes here. That would not cancel out this force F because now we have the two exact same forces that are pushing both clockwise. So we would actually need to put it on the other side of the pivot point. And if I put it at position X1, that gives me a torque that is, so for the 2F force, right, that would be 2 tick marks away. 2 tick marks, and then a force of 2F. And that would give me positive 4F, and those would cancel each other out and give me equilibrium. It would give me a net torque of 0 when I add them together. So my answer, again, for this one would actually be that, yeah, in this case, it'd be at that position X1 on this. Okay, so let's take a look at one more. A uniform meter stick, so blah, 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 all the same. It has a downward force F right here. An upward force of F over 3 is then applied somewhere, right? So it's 1/3 of what the original force was. So think about what we were talking about. If torque is proportional to radius and force, if the new force is only 1/3 as big, right? That tells me that the radius is going to need to be 3 times as far as what it was originally. Okay? So if I look at this, it was 1 tick mark. It needs to be 3 times as far. And so if you think about the way we've been doing stuff, this is an upward force. So again, if I put it over here, this would be going clockwise. This is going clockwise. So that would actually, they wouldn't be canceling each other out. So we got to, be careful with the directions. This is a downward force. I need to put an upward force 3 times as far. So 1, 2, 3. So this upward force of F over 3 would be able to cancel it out. It's 3 times as far. So I don't need to have as big of a force to cancel it out. So we would be at position X4. Okay? So as long as you approach problems knowing that knowing what equilibrium means, it means the net torque is 0. And if we just combine those two torques, they need to cancel each other out. All right? So good luck. I will see you all in class and have a good time.